Hello, dear students. I am Samir Velankar. I welcome all of you to this another video on expression evaluation. In this video, we will be seeing how to convert infix expression to postfix expression. Well, you already know that in the very first video of this series, we saw how to convert any infix to postfix. But we will be learning computer algorithm to convert infix expression to postfix. Now, the algorithm that we are going to learn, contains many terms. But the problem with that terms is that the reader doesn't understand that terms till the algorithm is understood. So the one is locked in the other. But anyway, let's see some comments about the algorithm. Let I be the infix expression. So you know that we want to convert infix to postfix. So let us say I, capital I, is the infix expression, and let P be the empty postfix expression. So we will start with the postfix expression P. P is the postfix which we want to find actually. I has to be converted into P, and P is initially empty, empty string, we will say. And let S be a stack, initially empty. So here also in this algorithm also we'll be using a stack. But listen, this stack S will be storing operators of infix expression. So if you imagine a stack S, which is last in first out, okay. So in this stack, we will be pushing the operators like slash, minus, multiply, and all that. All right. So it is going to be actually an operator stack. This is an operator stack because the stack is going to store only the operators. Note that this stack S may store open bracket also, because open bracket also is one of the operators only in one of its own kind, because brackets are to be solved first. Now this stack, S will store all the operators, you know that, but it will also store one special symbol. Look at this symbol. We will store some symbol like tilde. Now this tilde is such a symbol which never appears in the infix expression. Check my words. We know multiply, slash, minus, plus, brackets can appear in the infix expression. Tilde doesn't appear anywhere in the infix expression. So we will store this tilde at the bottom of the stack. That is the very first symbol pushed on the stack is going to be tilde. If you dislike this symbol tilde for some reason, then you can put some other character like comma. How about comma? Because comma also doesn't appear anywhere in the infix expression, assuming it doesn't appear. Or you can put some other character which will never appear in the infix expression. Now, why we are doing this? Why we are pushing some unrecognized character at the bottom of the stack will be learned at the end of this video. But listen, this stack is initially empty, and we are going to push one special character in the beginning inside the stack. So what next we have, you can check here that we have got lot of operators, isn't it, in the infix. Like we have got operators like plus, minus, star, slash, and bracket, open bracket, and close bracket also will be treated in a kind of operator itself, because brackets are to be solved first. Then we define priority of these operators. Now in this algorithm we'll be defining two types of priorities. First one is incoming priority, ICP, and second is in stack priority, ISP. Okay, just don't worry about all this table right now. My suggestion to all of you is you go through the algorithm with me, and while learning the algorithm you'll ultimately come to know what are these two terms, ICP and ISP. Okay, so now let's see the algorithm. This is all given. What? I is the infix which we want to convert it into postfix. P is the empty postfix. P is an empty string, and S is a stack which is initially empty. Let's take an example. While running the algorithm, let's take an example. Imagine this is the infix expression given. Now, I have purposely taken a very complex infix expression. I like this challenge. This infix has to be converted into postfix. First, let us manually convert this into postfix and then let's see the algorithm. What will be the postfix notation of this? First of all, you will solve brackets, correct? But within the bracket, there is one more bracket. You see the nested bracket, isn't it? This one, this one. So this has to be solved first. So this will be DE multiply, correct? Then C plus. So it should be CD multiply plus, correct? Then it should be B upon. So B C D slash, and then it should be F. So F slash. I am just solving it in one step. Okay. You can check that this is going to be the postfix. Then comes A into. So it should be A B C and then into, and then it's going to be into G. So it should be G into. Okay. So this is supposed to be our postfix expression. Note, the I is the input, infix expression, and this should be our output, postfix expression. Okay. So how do you start? You see that our algorithm starts with the empty postfix. Check the cursor. P is the empty postfix. Okay. And X, as usual in the earlier algorithms, X is going to give us the next token of I. So we will scan the I from left to right. Left to right, we are going to scan, and every time we will get a symbol that is token and store it in X. And S is the stack, which is actually initially empty. Okay. Initially it is vacant. So this is an empty stack. Let's start the algorithm now. All the best. The algorithm infix to postfix, check this, is going to take infix and empty postfix. P is empty right now. Now, to start with the algorithm, what the algorithm does is it push special symbol tilde. So tilde is pushed. Check the stack here. Check it. Tilde is pushed on the stack. Okay, such that ISP of tilde, ISP, check this, ISP of tilde is 0, that is least. Now you can read ISP right now as priority of tilde, okay? Precedence of tilde. Precedence of tilde is 0, it is least. Let's see what it means, but I'll better write it here. Priority of this tilde is 0 and it is least. Remember this. Okay, okay. Now the entire algorithm is controlled by the while in infix expression I is not finished. Continue. So infix expression I is a very big infix expression, and we start scanning the infix expression from left to right. So let's go into the while loop and let's take the next token. X is equal to next token of I. So please keep an eye on the infix expression now. Here is the cursor. Check the cursor place. First token that will be taken is A, isn't it? So X is equal to next token. Check the cursor place. X is equal to next token of I is going to be A, small a. And then we ask what was this token that we have taken out from I. Now there can be only 4 possibilities. You have to understand this. Hello everyone. There can be only 4 possibilities. X can be operand like ABC. X can be operator like multiply, divide, or plus, or addition, or subtraction. X can be open bracket. Yeah, bracket open. And X can be close bracket. Isn't it? It can be only either of these 4. It can be operand, it can be operator, it can be open bracket, it can be close bracket. That means when we ask, check the cursor place, I am encircling. When we ask what is X, there are going to be only 4 questions. Is it operand? Is it operator? Is it open bracket? Is it close bracket? So what is X right now? See, X is small a, isn't it? The very first operand, and X is really an operand. So what do you do when we get an operand? Check this. Whenever we get an operand, we simply add that X to postfix P. That means A, which is an operand, check that, is added to the postfix. Check it out. Postfix was empty initially. Now postfix is A. Tell me, aren't we on the correct track? What should be our final postfix? Check the cursor place. Postfix should start from A, and postfix has begun from A. Okay. So good. So x is an operand. This condition was true. So we added x to postfix. From now onwards, you remember, whenever x, that is token, is an operand, it is so simple. If x is an operand, then simply add x in the postfix. So what happens next? The else will get dropped, all the else will, because the if was true and we have the nested if else here. So what we are going to do after that last else is we are going to go back to while. So only one of the four conditions have become true. As x was an operand, we have added it in postfix and we will go back to while. Now the while here, the while is going to again check infix I is not yet finished. We have long way to go, lot of symbols, isn't it? So x becomes equal to next token again. So each time the while repeats, we are going to take out a token from I. And now the token, check the cursor place, is multiply. Isn't it so? It's an operator. So now the token is no more a. X is now multiply. So what happens then? As x is, the token is multiply, it is an operator. So after x is equal to next token of I, we check what is it? What is it? Oh, this is okay. Is x an operand? We will check. No, no way. X is multiplication. So else we check. Is x an open bracket? Not at all. Then we check next else. Is x the close bracket? No. Then we go to last else here. Check last else. And we are sure that the x is an operator. So quite a complex thing that I have written here. So just ignore it right now. Okay. This is operator case. If x is operator, this should run. But just ignore it at the moment. What happens if you get an operator? If you get an operator, the rule is so simple. If you get an operator, simply push that operator on the stack. See, x is an operator, x is multiply. So simply put multiply on the stack. But there is a rule here. The rule is also very easy. You want to put multiply on the stack, correct? You want to push multiply on the stack. But before you put multiply on the stack, you check who is the topmost symbol of the stack. The topmost symbol currently of the stack was tilde, because before this, before multiply went on the stack, only tilde was there. And you wanted to put multiply on the stack, isn't it? Because multiply is an operator must go on the stack. Now the rule is the incoming operator, that's the word, incoming operator must have a higher priority than in stack operator. In stack operator is tilde. Tilde is on the top of the stack. In stack, check the word. In stack operator is tilde and incoming operator is asterisk. Then incoming operator asterisk must have higher priority than tilde. So what is the priority of tilde that we have fixed? Initially in the algorithm, 0, very low priority of tilde. Asterisk will definitely have higher priority than tilde. We are going to fix the priority of asterisk higher than tilde, and asterisk will nicely supersede tilde. I hope you are understanding. What's the rule? Whenever you are pushing any operator in the stack, then that incoming operator must have greater priority than the in stack operator. In stack means the topmost operator of the stack. Okay, I think I have shouted enough. This was only to emphasize the fact that you remember this rule very well. Okay. Now what's the next token? After operator case, we'll go back to while. It is understood. So the next token now, as you scan the infix after asterisk, is going to be open bracket. Check that. Check this infix. After A into, now you have open bracket. So now this x is going to be open bracket. Okay. Now whenever you get an open bracket, that's again a easy news for us. If x is open bracket, don't check anything. Simply push open bracket on the stack. Simply push it. We can say it like this also, that open bracket whenever is going in the stack, it has highest priority, because open bracket can supersede, can go on top of anyone. See this incoming open bracket. Incoming open bracket doesn't have to wait for anyone. Whoever is on the top of the stack, whichever operator is on the top of the stack, open bracket can easily go on top of anyone because it has highest priority. Okay. Now let's see the next operator. Next token. Next token is B now. Check the cursor place. After the open bracket, next token of I is B. So if B is the next token, if B is the next token, what is it then? Which case is it? Now X is an operand, isn't it? What do you do when X is an operand? Come on, if X is an operand, check the cursor place, then simply add that operand X to the postfix. So this time postfix P, which was simply A, will now become A followed by B. You are simply adding the operand to the postfix. I hope you are understanding it, isn't it? So which cases have you seen till now? Just summarize it with me. If the next token is an operand like A, B, C, then very simple case, simply add it to postfix. Okay. Second case, if X is open bracket, good news. Open bracket will be simply pushed on the stack. Don't look at top of the stack. Don't worry. Simply push open bracket on the stack. Third case, if X is operator, then that operator must go on the stack. Remember, the operator should go on the stack. But before you put that operator on the stack, check the topmost operator which is currently on the stack. And the incoming operator, whichever is going in the stack, new operator which is going in the stack, must have higher, greater priority than the topmost operator. Only then that incoming operator can nicely sit on top of the topmost operator. Okay, three cases we have learned. Okay, let's see the next token now. After B, check the cursor place. After B, we have division. Okay, so the token X is now going to be division. So division is an operator, and you know operator must go on the stack. So we are about to put this division on the stack. Let's try to put division on the stack. But wait. Before putting any operator, check for the priorities. What is the rule? This is incoming operator. Who is incoming? Yes, division is incoming. Division is going in the stack. Then division must have higher priority than the bracket. Isn't it? Because bracket is topmost. Okay. I'm going to tell you something which irritates the listener. I mean, in the class, I have seen many students reacting something like they will throw something at me in anger. Correct or not? But once this is understood, the anger is really converted into happiness. Let's see. This division, this division should be pushed on the stack. Correct? This is the incoming operator. What is the rule? Incoming operator should have higher priority than in stack operator, isn't it? Correct? Now, what is the in stack operator? Open bracket. And you know open bracket has highest priority. Just now I said open bracket can go on top of anyone. But the same open bracket, once it is in the stack, once it goes inside the stack, then it has least priority. This is the point on which the students get irritated. See, the point is when the open bracket at any point of time is coming in the stack, suppose this open bracket is waiting and it has to go in the stack, then it doesn't have to take anybody's permission. Open bracket while coming in has highest priority and it can go on top of anyone. But when the same open bracket resides inside the stack, then that open bracket has least priority. So are you understanding you are having two types of priorities? Incoming priority and in stack priority. Okay, now we know this. Now, incoming priority of open bracket is maximum. When it is coming inside the stack, it is master. It can supersede anyone. But when the same open bracket goes inside the stack, once it resides in the stack, then it's a slave because it has lowest priority. And then anybody can go on top of this open bracket. So in one sentence, I can tell you, if you understand this, surely I hope you will understand that open bracket can go on top of anyone. Open bracket can go on top of anyone, and anyone can go on top of open bracket. Oh wow, what a sentence. Yes, open bracket can go on top of anyone because when open bracket is coming in, it has highest priority. So it can go on top of anyone. But when the same open bracket is on the stack, then that open bracket which is in the stack has very low priority. Then whoever is coming in will surely have high priority. And you know, the rule is incoming symbol, incoming operator must have high priority, then in stack symbol. So slash has higher priority than in stack operator. I hope you understand. Too much of talking I am doing, but that's necessary. You know how much time I spend while teaching this in the classroom? Around 2 hours. You won't believe. This algorithm is taught by me in 2 hours. There are a lot of other things which are raised by students, but slash has now gone on top of this this bracket. Okay, let's continue. What's the next token? After slash, we have again open bracket. Watch it out. After slash, check the cursor, we have open bracket. Now, open bracket is an operator. Is it? Just check this. Open bracket is the next token, isn't it? What did we say about open bracket? Whenever we get open bracket, check the cursor place. Simply push it on the stack. Don't check. Don't worry. Open bracket will go on the stack. No doubt about it. Has gone on the stack. This is where open bracket resides. Because when open bracket is coming in, it has highest priority. Now open bracket can go easily on top of slash symbol, isn't it so? But now once the open bracket is in the stack, it has very low priority. Okay, let's see next. Now the next token here is plus. Oh, I'm sorry, C. I'm so sorry. C is the next token, isn't it? So if C is the next token, C will be inside X. Now we will have X equal to C, X is C. What do you do with this? It is an operand. Come on, it's an operand. Check the first case. As X is operand, simply add it to postfix. So now the postfix becomes ABC. Oh, check it. We are on the right track. We already know our postfix. Final postfix should be A, B, C, D, E star and all that, isn't it? We are on the correct track. Okay, what's the next token now? After C, we have plus. Now plus, I'm overwriting this. Plus is an operator. Then plus must go on the stack, isn't it? I'll just make some room here. Okay, just make some room. Plus is an operator, so plus must go on the stack. But what is the rule? If you want to put plus on the stack, check the topmost symbol of the stack. Now you see plus must go on the stack. Check the topmost symbol. It is open bracket. Now the plus, the incoming plus, is really having higher priority than open bracket. Because once open bracket is in the stack, it has very low priority. So anyone can go on top of open bracket. So plus goes on top of open bracket. Good. Okay. So what's the next symbol? The next token is going to be D. And D, check that D is nothing but an operand. As D is an operand, we will simply add D to the postfix. Operand is added to postfix, isn't it? Now what next? Which is the next operand? The next operand is into multiplication. Now watch. Multiplication is an operator, isn't it? An operator must go on the stack. But there is a rule. Incoming operator must have higher priority than in stack operator. In stack operator now is plus. The world knows that multiplication has got higher priority, isn't it? Incoming operator multiplication, sorry, is having higher priority than in stack. So multiply can supersede plus. Okay, let's see. So let's see the next operator, next token. The next token of I after multiplication is E, and E is the operand, isn't it? So E goes in the postfix. Now what is the next token then? Next token, next token is close bracket. This is interesting now. First time we have got this token close bracket. Okay, let's summarize again. What are the types of tokens and what action you take? If the token is operand, very good news. If it is operand, simply add it to postfix. If it is open bracket, again a good news. Open bracket simply goes on the stack, blindly goes on the stack. Push it on the stack. What about operator? Operator also goes on the stack, provided the topmost operator of the stack, compared with the incoming operator. Incoming operator must have higher priority than the topmost operator. Only then the incoming operator can go on top of existing operator. Now, this is the fourth case that we are getting. We are getting close bracket. First time we have got close bracket. Now, when we get a close bracket, what you do is you simply pop whatever operators are there in the stack till the open bracket. Check this cursor place. You pop the star, you pop plus, and you pop open bracket also. But star and plus which you pop are simply added to postfix. Whatever you pop is added to postfix. And the bracket that you pop after that, because you got a close bracket, isn't it? You got a close bracket, therefore you are popping everything up to open bracket, and that too up to first open bracket. You note we have one more open bracket. Check the cursor place. But we are going to pop everything only up to first open bracket, and we are going to simply discard that open bracket. We are not going to add open bracket anywhere, but really we are going to add asterisk and plus to our postfix that we have added, and we will discard open bracket. We will pop open bracket also, and we'll discard it. Nice. So what is the condition for close bracket? Whenever you get close bracket, check here the cursor place. Whenever you get close bracket, till the stack top does not show open bracket, till you don't encounter open bracket, pop from the stack and add whatever you have popped, you add it to the postfix. And most importantly, after you get an open bracket, suppose now you have reached the open bracket, you come out of the while. Look at this while. You come out of the while and you pop once again. You pop. That is what you do by discard open bracket. Extra pop you do when you get an open bracket. You come out of the while, pop it again, so open bracket also gets popped. Nice. Now what's the next token? Oh, this is very big expression, isn't it? But I like this. You understand the algorithm in and out by understanding a complex expression. Come on, what's the sense in taking a very small expression and running the algorithm? We won't even get all the cases if we take a very small algorithm, so very very small expression. Okay, after the close bracket, the next token is division. Okay, this is so much interesting. You see, this token now is division. X is division now. All right. So what should we do? It is an operator. If it's an operator, then that operator must go on the stack. Correct. But wait, the rule is the incoming operator must have higher priority than in stack operator. But you note the incoming operator is division and in stack operation is division, then both have equal priority. Come on, the incoming operator must have higher priority than in stack operator. Well, you cannot put slash on top of slash. I hope you are understanding. Slash cannot supersede slash. So what you will do, as incoming operator is waiting outside, hello, slash is saying I want to go in the stack, but there is already an equal priority operator on the stack. So what is done is this slash which is on the stack is now popped finally. Long time it was waiting on the stack, isn't it? Slash is now popped, and slash will be added to the postfix. Now what? Now slash, the operator is still waiting out, is checked with the in stack symbol. In stack symbol is bracket, and when bracket is in the stack, yes, when bracket is in the stack, it has least priority. So now this incoming bracket can go on top of open bracket. I hope you have understood this. I hope you got this. So just see with me here. I'm showing a possibility here. Let's stop running this, but I'm showing a possibility here. Suppose I am having tilde on the stack and plus and slash. Currently, I am having this. Currently, you see, slash can go on top of plus because slash is having higher priority than plus. And now imagine incoming symbol is minus. So minus wants to come in the stack. But can minus go on top of slash? Impossible. See this incoming operator minus should have higher priority than in stack operator, but slash is having higher priority. So this slash is popped, correct? And added to postfix. Now you watch again. The incoming operator is minus. It still wants to go on the stack, but minus and plus. See this in stack operator plus have same priority. But the rule is that the incoming operator must have higher priority than in stack. So this plus is also popped and added to postfix. Now you watch, minus is still waiting out, isn't it? And it wants to go in the stack. And you note minus has higher priority than tilde. You know that priority of tilde is least. That's the way how we have fixed it, correct or not? Priority of tilde very early in the class, in this lecture, I told you that tilde has least priority. Then minus can go on top. I hope you have understood this case, operator case. Okay, let me clean this. So slash was popped and this incoming slash was pushed. What's the next operand now? After slash, we have F, isn't it? F. Now F, I'm overwriting this. I'm so sorry. I just write it neatly. Okay. F is nothing but an operand. So F goes in the postfix. Check this postfix. F goes in the postfix because it is an operand. Now the next symbol. Next symbol is close bracket. Observe. Next symbol is close bracket in the infix. So what will you do with close bracket? Yes, you know the case now. Whenever you get a close bracket, you pop everything from the stack up to open bracket. Pop everything from the stack up to open bracket, and whatever we have popped, simply add it to postfix and discard the open bracket which is there in the stack. Don't add that open bracket anywhere. So this slash will be popped and added to postfix. Look at the postfix. I have added that slash and slash goes out and bracket also is popped. I guess you followed it. Okay, now after close bracket we have got into, isn't it? Now this into is nothing but an operator. So x is going to be into, and into must go on the stack. Again the same problem. You see, now you know that, isn't it? Can into go on top of into? Never. The incoming operator should have higher priority than in stack operator. So what we do is we will pop this into. A lot of time into was on the stack. It's time to pop it and add it to postfix. Check, I am adding this into postfix. And now the incoming operator multiply can go on top of tilde because tilde has least priority. Yes, everyone. I guess you followed it. No problem. I hope so. After so much of discussion. Next thing. Next operator is G. Next token is G. But G is an operand. So simply add it to postfix. Check the postfix. I have added G, isn't it? And that is it. G was the last. Good Lord. G was the last token in infix. So now this while loop, check the cursor place. The while loop, while infix expression I is not finished, is over. This while loop is over and we come out of the while. But wait a minute, when we come out of the while, there are some operators still pending on the stack, isn't it? Now these operators, whichever operators are pending in the stack, are simply popped and they are added to the postfix. So you know that there was one operator multiply still pending in the stack. We simply pop it and we add it to the postfix. So this postfix becomes the expression as shown. After popping this multiply, what remains is tilde and we leave tilde as it was in the beginning. So you check the postfix expression. Lot of hard work we did. In fact, you had immense patience in listening all this. But I'll tell you, the end result will be very nice. The postfix is what exactly we needed here. Check the cursor place. This was the postfix. Okay, I will clean the slate now, and let's see. A very very simple infix expression. I have gone opposite. I will now take a easy example. Suppose infix expression a plus b into c. Tell me what do? You use a stack, put tilde initially, tilde has least priority, and T is the empty postfix, isn't it? X is the next token. Now X is first time going to be A, and A is the operand, so we add it in the postfix. So P, which was empty, now becomes A. Now the next token is plus. What would you do when you get a plus? Plus is an operator, and you know operator must go on the stack, correct? And plus can go on the stack because the current topmost symbol is tilde. Tilde has lower priority. So incoming operator has higher priority and plus can go on top of tilde. Now the next token in the infix observe is B, but B is an operand. So you simply add that B in the postfix. So postfix becomes AB. Now the next symbol is multiply. Multiply here, multiply is an operator and multiply must go on the stack, correct or not? Can multiply go on plus? Yes, plus has lower priority. Incoming operator in multiply, world knows multiply has higher priority than into. So multiply easily goes on top of plus. Okay. Next symbol that we will get, next token we get is C. But C is an operand. So as C is an operand, we will add it to postfix. And now you watch after C, this infix expression is finished. So as this infix expression is finished, we won't say that our algorithm is finished, because when the infix expression is finished, there might be a few things pending in the stack. Some operators are still pending in the stack, and whatever is pending is simply popped. So star is popped, plus is popped, and it is added one by one to the postfix, and tilde is simply kept on the stack as it was. So this is the postfix A, B, C star plus. Everybody knows for A plus B into C, the postfix is A, B, C star plus. Okay. So this is how we convert an infix expression to postfix. Now, in the beginning of the algorithm, I have defined a table here, the incoming priority and in-stack priority of various symbols. I call it as ICP and I call it as ISP, incoming and in-stack priority. Now you watch very interestingly, bracket, open bracket. Open bracket is not having incoming priority at all. Now my idea for this is that I am going to, whenever open bracket comes in, I'm going to simply push it on the stack. I'm never going to compare, I will never compare priorities. That means the if statement written is, if X is open bracket, then push X. Push X on the stack S. I am not even going to check the priorities. If I am not going to check the priorities, then what is the sense in defining the priority of incoming priority of open bracket? I hope you are getting it, isn't it? But very interestingly, you watch that for that open bracket, I have defined in stack priority, and in stack priority is very low. It is 1. So once the open bracket goes inside the stack, its priority is very less. In stack priority of open bracket is least. Now you see, multiply and division have same priority in stack and incoming, 3, 3, but plus and minus have same priority, 2, 2, in stack and incoming. Both incoming and in stack are same, but their priority is lesser than priority of into and slash. Of course, has to be, isn't it? And now finally you see tilde symbol. The tilde symbol is not having any incoming priority. Why? A very silly question. Tilde will not have any incoming priority because tilde will never come in. Tilde is not in the infix. So how come during the algorithm execution, tilde can come in the stack? Tilde can stay on the stack permanently because we are going to push tilde on the stack. But tilde will never come as an operator in the stack. So there is no question of defining incoming priority of tilde, as it is never going to come in as a operator, but it will stay in the stack. So in stack priority is defined, and you see in stack priority of tilde is least, that is 0. So these are the priorities of the various operators. Okay. Now, so far so good. Now you check. You just help me here in scanning this algorithm on an example again. Let's take a very small example. Let's say the infix expression given is something like this: A multiplied by B plus C into D upon E. This is the expression. So what would you say? What will you do? The stack. S is going to store tilde first. I have still not told you why tilde is stored, but imagine that tilde is stored and its priority is least. Now, what will be the tokens? First token will be A. Now it is an operand, so simply add it to postfix. P becomes A. Postfix was empty initially. Now the next after A, next token is into. Now into is X. X is the next token. Must go on the stack, and it can go on tilde because tilde has lower priority always. Now what's the next token? The next token is open bracket. You see, watch, after star we have open bracket. So if the next token is open bracket, simply push it on the stack. That's what I said. Whenever open bracket is coming in, we don't have to check its priority. So we have never defined incoming priority of open bracket. Now the next symbol that we will get after open bracket is B. It is so easy. B is just an operand. So we'll simply add B to the postfix. Check the postfix. It is AB now. Now after B, the next token that we get is plus. So what are you going to do with plus? Plus is an operator. So plus will go on top of the stack, isn't it? Plus is an operator. Can plus go on top of open bracket? Yes, because open bracket once inside the stack has least priority. So plus can easily go on top of open bracket because open bracket has very less in stack priority. In stack priority of open bracket is less or least. Well, the next symbol here is C. So C is the next token, isn't it? Now, wait a minute. If C is the next token, then C is an operand. So simply add it to postfix. Now the next token is multiply. Observe, X is multiply. Then multiply must go on top of the stack. But can multiply go on top of plus? Of course, yes, multiply has higher priority than plus. No need of adjustment, isn't it? No need of popping any existing operators. Now the next token after multiply is D. Check this. D is an operand, so simply add it to postfix. Now the next operator that we get, or the next symbol we get, is close bracket. See that close bracket. Now close bracket whenever encountered, we just have to pop. We just have to pop everything from the stack till the open bracket, till this open bracket. But don't add open bracket anywhere. Simply discard the open bracket. But star will be popped, plus will be popped, and they will be added to postfix. Check that we are adding them to postfix, and bracket will be also popped, but bracket will be simply discarded. Okay, nice. So what's the next token now? Check the next token. After close bracket, we have division. Very interesting. Now you know, I'm sure you know. We are just revising. I want all of you to revise this very well. We have division now. X is division. Well, can division go on top of multiplication? Observe, no, it can't. Because incoming operator must have higher priority than in stack operator. So what will you do? You will say multiply enough. Your long time inside the stack. Time to go out and join the postfix. And now you see this slash is still waiting out, isn't it? It should go on the stack. And it can go on the stack because now the topmost operator is tilde, which is having very less priority. Okay. Now what is the next operator? The next symbol is E. X is E and E is an operand. So simply add it to postfix. And that's it. We have finished with our infix expression. Infix expression is over. But then when infix expression is over, we will come out of this while loop. Surely the while will finish. But after the while loop finishes, we will pop. We will pop remaining operators from the stack. So we will pop everything till the tilde, correct or not? We'll pop and we will add them to postfix. So the only operator now pending in the stack is slash. Slash will be added in the postfix. So slash is popped and tilde is left as it is on the stack. And this is the resultant postfix that we get. I hope you have understood the algorithm. Now, the operator case over here, check this operator case, says that whenever you get an operator, surely the operator must be pushed on the stack. Check this push operation. Operator must be pushed. So push X on S. But before you push that operator, check the incoming priority of the operator. X is the incoming operator. If it is less than or equal to in stack operator, then pop the in stack operator and add that in stack operator to postfix and repeat this. Whether you are understanding this while loop, you just check this case. If you have tilde, plus and slash, and suppose the incoming symbol is minus, so X is minus, this is incoming operator, then we are going to check incoming priority of X. You see that incoming priority of X, is it less than or equal to in stack priority of topmost? Now you see that incoming priority of X is genuinely less than slash. Slash is higher, correct or not? Sorry. So what you do is you pop this slash and add it to postfix. And then you again check what is the incoming priority of minus. Is it less than or equal to? Less than or equal to plus? Yes, minus is less than or equal to plus. Both are having equal priority. Then even plus is popped and added to postfix. Now you again check what is the incoming priority of minus. Is it less than or equal to tilde? No, minus is having a higher priority than tilde. So obviously this minus will easily reside on top of tilde. Check this case, check this case. This is operator case. And you just go through this entire algorithm, and I will encourage all of you to take any infix expression and run through these steps, run through the steps of these algorithm, so that you will understand this in and out. I hope you have already understood it. Thank you very much.